Hey, this is OXDF, and today we're looking at the Advent of Code 2015, Day 13, Knights of the Dinner Table. And we're doing Advent of Code because we're learning Rust. So let's go ahead and take a look at the prompt. Basically, we're looking for an optimal seating arrangement for a bunch of people, right? And so they give us this example. I'm going to skip through the text here, but basically, Alice, there's 4 people in this example. So Alice sitting next to each of the 3 other people gains or loses some happiness. Bob, so you get each relation. And so just because Alice 54 gains 54 sitting next to Bob, Bob gains 83 sitting next to Alice, that may not be symmetrical. There may be cases where, like Carol, I don't have an example here, but well, here, Carol loses stuff sitting next to Alice. Anyway, it doesn't matter. The point is they don't have to be symmetrical, but we're trying to maximize the happiness of the whole group. And so in this case, there's the example of if they sit, this is the optimal seating arrangement. And even though David gains 46 sitting next to Alice, Alice loses 2, but boy, we're looking for the max. As I'm doing this series, I solved the first, I think, 20 of these years ago in Python. I'm doing back into it in Rust, which is why we get an answer here and not the puzzle input. But I got the puzzle input here. We can take a look, and it's just like the example we had there, except for we've got, looks like 1, 2, 3, 4, 5, 6, 7, so 8 people around the table instead of 6. So yeah, let's see. Strategy wise, we're going to take a very similar strategy to what we did in day 9, where we're going to create a hash map where we can use that to map happiness between player A and person A and person B. We use a hash set to keep a list of the people. We will get all permutations, and then we can use the tuple windows, and this time we'll use the circular version to loop over each possible permutation and calculate a score. So we're going to need to parse all this data into the hash map. We're going to need to be able to calculate the permutations or orderings, and then we're going to need to do that loop. So let's go ahead and jump over into VS Code here, and I'll use my GenDay script here. And for day 13, I went over this script in great detail in video 0, which you can check out at the link up here somewhere. But basically, it's going to read me my input.txt here, so we have this nice and handy. And it gives me this nice stub that I can start with where I've read the input.txt into data. Unlike I talked about, day 9, I did this all kind of just in main. I'm going to work today out of just a struct. This makes it a little bit cleaner, and we'll call this a party. And so a party is going to have a happiness map, which will be a hash map. We'll need to come down with the hash map. And let's go ahead and define it. It's going to take in a string and a string, so 2 players, and it's going a tuple of 2 strings, and it's going to return a I size. And I size is just an integer. Now we're using a I means it can be plus or negative, which we need because we did see there's negative. I can't imagine that. Oh yeah, we need plus and minus, so we'll just work off that. We're also going to have a people, and that's going to be a hash set. We could just do a vector, but again, I want unique people, so we'll just do a hash set, and again, the names will be strings, like that. And that looks like, basically, that's our party. Now, I'm going to use, I could, create an empty party and then loop over adding it, but I want to actually use the implementation of the kind of from structure, and I showed this in day 2. Actually, I can show it, we can pull it up here. And I did it in a really simple case. So in this case, I said, take a vector of U32s, and create a present object. And then literally all I did was vec 0, 1, and 2 into the 3 pieces of a present. We're going to do something similar here. We're going to say from, in this case, string. So it's going to take in the string, which I'm just going to pass the entire input in here, for party. And now we can do function from, and again, it's going to take data, which I have to define here as a string, and it's going to return a party. And so what are we going to do? Well, first, we're going to say let mut p equals party. We need to define we're going to need a new party. So we can say like happiness map and call that hash map new, comma, and then people hash set new. So we are going to have to start with a new fresh party, basically. We're probably going to need, I'm surprised it's not yelling at us already. Let's run this real quick. We're going to need to import this stuff or use this stuff. Let's see. So if we give this a run, expected a party, but oh, well, okay. So we need to return a party. We can do that by just putting P here at the end. So that's fine. Now we'll return an empty party. Okay, here we go. So we aren't importing. Yeah. So we can do, tells us exactly what to do, but we know this. Use standard library collections, HashMap, comma, HashSet. Give it a semicolon, give us a space, and now we should be able to get an empty party. Like that. All right, and I was complaining because this stuff's not used, but that's fine. All right, so we've now created our empty party. Now we want to so we're gonna do our loop. We're gonna do for line in data.lines. We'll say, so the first thing I need to do, if we look at these lines, let's see. Where's my input.text? So we really need this name. We need this name. We also need the number, and we need to know whether it's gained or lost. And so one trick I'm going to try here is, oops, we don't need day 2 anymore. Let's get rid of that. Is I'm going to just replace, we can say, let's just do mod line equals line dot replace. In this case, we're going to replace gain with a space with nothing. Replace, and in this case, we're going to replace lose with a space with a minus sign. And this will allow us to, if you picture this, now this is going to be just negative 50 or plus 54. This will be minus 81. And so now we can just parse these as numbers. We don't have to worry about like, if it equals gain, do this, subtract, or blah, blah, blah. We can just sort of do that for us. I'm noticing my extension's not working. Give me a sec. Oh, reload required. Let's see if it just fixes. Maybe I'll fix it. There we go. Okay, the extension's working now. So we've got our mod line. Let's make this look a little more readable. And the other thing we need to take into account is I'm going to split on space, right? So I'm going to get Alice, Wood. This will now be plus 50 or 54, happiness units by sitting next to, and then Bob. But I actually get Bob period. So what I want to do is get rid of that Bob period. We'll actually put that at the front here. Trim. So trim will remove white space, but I can do trim end matches and put any pattern in there, and we will put in a string like that. So now we can trim the thing off the end. Okay, so now we got our mod line. Do let tokens equals mod line. Ooh, not module path. Mod line dot split, like on a space like that. So now we got our tokens. And we can now say, oh, actually, sorry, let's say, when we do a split like this, we want to do a collect at the end because we want to go ahead and get a vector of those so we can get them easily. And then it's going to complain to us because collect does a lot more than vector. So we'll type this as vec of strings like that. So now we got tokens. Okay, so now we can say let's do P1, P2, and happiness equals, we'll put this in a, so we can say P1 is going to be tokens dot, let's see, so P1 would be the first, would be token 0. And we're going to want to put that as a string, so we can say toString like that. P2 is going to be tokens, so 0, 1, this will be 2 together after the replace, 3, 4, 5, 6, 7, 8, 9. So here we'll come and say tokens sub9 dot toString. And then finally we need the happiness, which will be tokens sub 0, 1, 2. And this one we're going to do dot parse to turn it into a integer, and we'll need to unwrap that. And I think we are good there. Ooh, we're not happy. What do we do wrong? type annotations needed for consider giving a pattern type. So we can say, I guess we can do this yeah, so P1 string, P2 colon string, oops, let's do capital string, and happiness colon I size. Did that work? No, that did not work. Let's get rid of this again here and go P1 comma P2 comma happiness. What don't you like about this? We need a semicolon at the end here. Type annotations needed for string. I guess we could do it like this, maybe? String I size. Does that work? Okay. I don't know why I needed that, but we'll go with it. So now we've got our types. We've got our 3 items here. And so now we can just do what do we call the party up here? P dot happiness map dot insert. And so the value is going to be P1. It's actually going to be a tuple. And the tuple is going to be P1 comma P2. And then we're going to insert into here, what did I call it? Happiness, like that. So we save that. So now we've looped. Okay, so for each line we've gone through, we've cleaned it up, we've gotten tokens, we've pulled out person 1, person 2 and their happiness. We're now going to create into the map person 1, person 2 happiness. The other thing we need to do is do p.people dot insert. In this case, we're just going to insert P1. We don't have to insert P2 this time because every person shows up on both sides of the list, unlike the previous example where we were doing train times and it only showed they were reciprocal each way. Because we get different ones each way this time, we're going to get to P2 in a later loop, so that's okay. Let's see, we have an issue here. I bet it's an ownership thing. Let's see. Use move value of P1. Okay, so yeah. Basically, once I give P1 to this stuff here, I've lost ownership of it, and it doesn't come back. So what we're going to do here is do .clone. So we pass on something we don't care about, and we're good there. And that probably looks like all we need. Let's actually try this. We can come down here and we can say, so because we're using this kind of from structure, what we can do is we can say, let party, and we type that as a party, equals data.into, and that's it. Now we should have a party. We can come down here and do party. We're going to have to definitely debug print this because we didn't write a printer for it. I think it's still going to fail. We're going to have to add that derived debug bit. So we'll grab this and we'll come up here to our class. Come up here to our class, add that in. And now, I don't know how this got pulled in. VSCode likes to pull in random imports for me when it doesn't pull in the ones I want, and it pulls in the ones I don't want. So anyway, and if we look at this is kind of cool. We got ourselves a party which has a happiness map, which gives from Eric to Carol's 84, Eric to Alice's -51, and at the bottom here it also has the list of people, nice and neat for us. So I think we've got the data we need to have here. Now we just need to figure out what is the max happiness. So let's come down. Let's see. We'll come down here and we'll add a function on party. So we can do impl party, and then we can do fn max happiness, and that is going to take self, and it's going to return, in this case we just need an int, so we'll do an I size. That's just like that. And so we'll start off with creating sort of a let mut max hap equals, and we want to start with something incredibly low. We can start with 0, but it's possible that the maximum happiness is negative. It seems unlikely, but we'll come up with something kind of big like that. We'll just say looks like that. And if we get that back as our value, we'll want to go back and reevaluate because it means probably something's wrong. So now we can say for seeding in self.people.iter.permutations. I think it's like that, and we need to give it the length. So self.people.length. And I think that's going to fail because we haven't imported Found, oh, well, first it's failing because we're supposed to return an iSize. We'll just return 0 for a second. Actually, we can return max hap. Okay. So now we're failing because there's no method named permutations. We can fix that. We can use iter tools, like that, and we're going to have to add that to our cargo.toml. Iter tools equals, and we're being very lazy and just importing the newest. So that seems to be fine. So now a seating. So basically, we're going to get all the possible permutations, which is different orderings of the people. And so for each one, we need to go through and figure out what the happiness is. So we can say let mut hap equals 0. We're starting off at 0. We're going to do for, and this is, I love this part, p1 comma p2 in this, take the seating, and we need an iterator, so we'll create an iter. And now we can use circular tuple windows. This is going to be just like the tuple windows thing, except for now it's circular. So let's say we had, come down here real quick and scratch pad it. If we had, you know, 1, 2, 3, 4, like that, well then circular tuple windows on that is going to return 1, 2, it's going to return 2, 3, it's going to return 3, 4, and it's going to return 4, 1, like that. The tuple windows would return just these first 3, but tuple circular, it says, oh, go ahead and do a loop around once. And so now I get all the combinations around the table very easily. So with that, I can do for that loop. So now I'm going to get P1 and P2. So I'll say hap plus equals, and now I can calculate the happiness there. So we can say self.happinessMap dot get. We'll pass in the tuple. In this case, it will be P1, P2. And I think that's it. Or let me see. Does that? We'll trick here to see let hap equals and see what it tells us that is. That's an option of iSize. So we need to do an unwrap on that. Unwrap. Okay. Sweet. And that's where we get back an iSize. So it's unhappy here because we need, it says expected a. So we'll put that in front here. And what's unhappy here? Try using conversion method toString. As you say, O compiler. toString. toString. And now we got that. Now we look happy there. So we'll say, instead of let hap, we'll say hap plus equals. And I think we're looking good. So now we'll do that loop. Oh, so we need that. We also need to do self.happinessMap.get. Map our same thing. Now we need to do p2.toString, comma p1.toString, like that. Dot unwrap. If I can spell. So basically, we're going to say for each pair of people going on the table, we're going to say, give me the how happy P1 is sitting next to P2 and how happy P2 is sitting next to P1. We're going to add those all together, running around the table to get a happiness. And then we'll say if hap is greater than max hap equals hap. And at the end, we just return max happiness. So if this works, which I don't see why it wouldn't. Let's see. We should be able to just come down here and say party.max happiness, and we can even get rid of the debug print and just give it a roll. Because we're definitely gonna be doing this a lot of iterations. Let's run it quickly, and we get 709. Quickly, I mean, let's run the release version. And 709. That's right. All right. So part 2. We realized we forgot to add ourselves, and we're apathetic towards the whole thing. So basically, we're going to add ourselves in with relationships where you get a happiness score of 0 for everything. So let's figure out, and then we rerun the thing. So we can come up here. I think what we'll do is we'll come here and say fn add me. We need a mutable self. And that's not going to return anything. And we're going to say, there's a couple. So we'll do this 2 ways, I think. First thing we need to do is we'll say add me, and we'll actually go ahead and do this robustly. So we'll say for p in self.people I think we need to make that an iterator. Let's see what happens. I think we need to make that an iterator. We'll find out. Let's see. Yeah, cannot move out of self.people. Let's make that iter. That seems to fix it. Okay. So, well, for each person, we're going to do self.happinessmap.insert. We will do p.toString, comma, 0xdf dot toString, and the value will be 0. And we will do that same thing, except for this time we will put that I'm happy and everyone's happy to sit next to me. So, or I guess not agnostic to sit next to me. And so now that we have that loop, we can do self.people.add, not add, dot insert, and we'll do oxdf.toString. Oops. oxdf.toString. Like that. So now this add me function just adds me to the thing. And so now we should be able to come down here and say party.add me. And then down here we can do party.max happiness. And it doesn't like this. What's unhappy? Cannot borrow is mutable. Oh, I should, we gotta make mute party and run this. 668, I believe that's correct. I lost my window here. You don't need a calculator. 668, we got it. So I did say I should show 2 ways. So we can do it this way. There's a sloppier, like an easier way to do that. So we can get rid of this, and we can get rid of this. Comment that out. So instead of doing that, we could just come down here and say party.people.insert oxdf.toString. So we can add myself here, right? Oops, I don't need that. And now I've added myself. And now what's going to happen here if we just run this is it's going to fail because it's going to try to look up me, and it's going to say it got a none back. So basically, let's see, what line are we at? 16. So when I'm doing this loop here to add the happiness in, at some point, oxdf is going to show up in here. This unwrap's going to fail because it's not going to get anything. So what we can do is in this, probably want to spread this out some, but let's say self.happinessmap.get. We're going to get the thing. Instead of saying unwrap, we can say unwrap or 0. Like that. Let's see, what's the need here? Consider borrowing. I gotta borrow my, okay. I'm gonna borrow on my static 0. Don't understand that, we're gonna go with it. So if I say unwrap or 0 there, and I can say unwrap or, I guess I'll borrow again, it's 0. Now what it's saying is, if this fails, if it looks up in here, if this get fails and looks up and gets nothing, return just a 0, which is what my default value is, right? If everyone was like 10 happy to sit next to me, I could put a 10 in here too, and I would be fine. So now we can do this and it won't crash, and I get the correct answer still. The reason I think this is actually worse is because it now masks, if I have some sort of error in my parsing or some sort of key, it just gives me a 0. And so there's a good chance if I screw something up, I can get back wrong answers rather than knowing I broke something. And so I think that's why I like the other answer slightly better. Of actually just adding myself in, loop. It's a little more work. I got to loop over the whole thing and add me into each pair. But I think it's a little bit safer. So with that, I'm going to call the video here. Thanks for sticking around with me till the end, and I will talk to you next time.